Check if it is an identity. I am Anil Kumar. Welcome to my series on trigonometric identities. Here is a challenge question for you to attempt. Is the following equation an identity? State any restrictions. Well, restrictions will be that denominator cannot be 0. For that, you need to factor and figure it out. But let's begin with the left hand side to show that left hand side is equal to the right hand side. If it is true, then it will be an identity. So, what is left hand side equal to? So, we are given it is sine square x plus 2 cos x minus 1. Sine square x can be written as 1 minus cos square x, right? Since you know that cos square x plus sine square x is equal to 1, and that is to say that sine square x equals to 1 minus cos square x, correct? So we are going to replace sine square x with 1 minus cos square x, and we'll rewrite the left hand side as 1 minus cos square x plus we have 2 cos x minus 1 over. Here we have sine square x once again. I'll again write it as 1 minus cos square x plus 3 cos x minus 3, correct? Now 1 minus cos square x, and here we have 1 minus, so they cancel. So we have minus cos square x plus 2 cos x over 1 minus 3 gives me minus 2, right? So I could write this as minus 2 here. So we have minus cos square x plus 3 cos x minus 2. Let us rearrange, factoring out minus cos square x minus cos x from the numerator. So we get minus cos x from the numerator, and we get here cos x minus 2. In the denominator, we can take out this minus outside and then factor the inside terms. So inside, what do you get? Let me first rewrite with taking out minus. So we get cos square x plus becomes minus 3 cos x plus 2, right? Since we factor out minus. Now these two minuses, they cancel, right? So we can rewrite this as cos x times cos x minus 2. The denominator can be factored 2 times 1, both negative, right? So we have cos x minus 1 times cos x minus 2. So now we can cancel cos x minus 2, and we get a very simplified expression, which is cos x over cos x minus 1. Do you see that? Now, from here, to get the right hand side, what we could do is rationalize, right? So if I rationalize, I get cos x minus 1. So I could multiply this by another term, which is cos x plus 1, correct? And also divide by cos x plus 1. So that will give me what? Well, that gives me cos x times cos x plus 1 in the numerator, and the denominator will be cos square x minus 1, right? Do you see that? Now cos square x minus 1 is minus sine square x, and the numerator gives me cos square x plus cos x, as we are expecting, right? So we get cos square x plus cos x in the numerator, and the denominator is minus sine square x. Do you see, this is equal to the right hand side, correct? So this is in fact an identity. Perfect. Now let's get back to the restrictions. We see cos x is in the denominator, and plus 1 and minus 1. Both the terms are there. So in that case, we also have cos x equals to 2, but cos x is maximum 1, right? So the restriction is what? So let's write down the restrictions also. Restrictions are that cos x is not equal to plus and minus 1, since we have those terms in the denominator. Is that clear to you, right? Of course, sin x is not equal to 0 either, right? So those are the two restrictions which we have to place on the given thing. I hope that makes sense, correct? So that is how you're going to prove this particular identity. Well, at times you may have to do from both the sides to reach at this step. However, this was a critical step and I hope you have understood this concept. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. You can also send an email on the address given to learn directly from me. Thanks for your time and all the best.